All right, good morning. So, today you are going to get some time to work on your Unit 2 lab discussion. I just want to do a quick review of, kind of the content you need in order to be able to get through this. But first, let's make sure you know where to find the discussion. So, Chemistry A homepage, shortcut to the assignment is right here, but for the recording's sake, I'm going to go the long way. So, atomic structure, Unit 2, launch that one. And then scroll down to 2.06. All right, so pictures, once you have them, go here, but the assignment is in this discussion area. So click on the title there. Then you're going to click on the title one more time. You can see your questions here. You can see them again here. All right, but you have to click on the title a second time to get the Start New Thread button. But which of your 24 wells had indications of a chemical reaction? How were you able to tell that a chemical reaction occurred? And then you've got which of the 24 wells had indications of a physical reaction? How could you tell that happened? Report both mixing and evaporation. Um, so just so you know, to get full points for these two questions, you should address all 24 wells. You need to share your observation for each pair of chemicals, and you should be making a judgment as to whether or not what happened was chemical or physical. All right? So even if it seemed like nothing was happening, you were mixing the two things together, which is a physical reaction. Okay? That's the biggest area where people lose points on this assignment is you sit there and you only talk about one or two that seemed interesting. You've got to talk about all 24. All right? And then question number 3 says make a general statement about whether your hypotheses are validated or rejected. So prior to doing this lab, what did you think was going to happen? That's going to be your hypothesis. Did you think there were certain ones that were going to have chemical reactions, or did you think that there were going to be some that you knew were going to dissolve and therefore be a physical change? All right. So that's this question. There's one part is sharing your hypothesis and making sure you discuss whether or not that hypothesis was supported or rejected by what you saw. But don't forget the second part. Must your hypotheses be correct to be successful in this laboratory? This is a yes or no answer, but you need to explain why you say yes or no. So again, to get full points, make sure you answer these completely. But let's do some review to make sure you know how. So, first off, for the first two questions, you're going to have to go through those observations that you recorded from when you did the lab. And you're going to have to decide if chemical changes happened or physical changes happened. All right. So, just kind of going over the definitions of these again, we talked about this earlier. Chemical changes cause the chemical that existed to become a new chemical. All right. So, like water turning into hydrogen and oxygen. It's not water anymore. For this lab, these 5 signs of a chemical reaction, that's going to be what you want to focus in on to be able to tell if you're observing a chemical change. All right, so see if you can recall what the 5 signs of a chemical reaction are. Pause it if you need some more time to think about it. But the biggies for this lab are going to be color changes and a gas being given off because those are easy things to see. All right. Energy being released or absorbed, you can't see that happening, and we're not taking temperatures. So that's not going to be something that you'll be able to use for this lab. And a precipitate forming maybe in the last set because that's two liquids combining, but probably not in this lab. All right. But really focus off on if you see bubbles happening, that's a gas forming. Or if you see any, you combine two clear thing or a white thing and a clear liquid and suddenly it turns pink, hey, that's a color change. Okay, so focus in on those as your evidence for a chemical change. All right, and then physical changes there's going to be a lot of them in here. That's when you don't see these signs of a chemical reaction, then there's something physical going on. It could be as simple as they just mix together. All right, It could be as simple as forming layers. Like if the oil sits on top of the solid white particles, all right? One I know you're going to see in this lab is dissolving, all right? So if the solid disappears as you stir things up, that's dissolving. You can also confirm that it's dissolving because when you let it evaporate, the solid will come back, all right? Which is why the physical changes can be reversed. So just know that if these don't happen, then it's a physical change, all right? So I get a lot of people who sit there, because I will say most of the lab is physical changes. Don't worry if a lot of things are physical changes, all right? It's not going to be split even down the middle or anything close to that. So don't be afraid to overuse this. The only time you should say chemical change is if you're seeing really one of these two, because you can't see the rest. So some examples, and you are more than welcome to use this for your lab, because I know some people might not have chalk at home and I don't want you to have to go out and buy chalk. But this is what I saw when I combined chalk and these liquids. All right, so chalk and distilled water. Initially they mixed together, but as time went, the chalk settled or fell to the bottom. So thinking about my 5 signs of a chemical reaction, no color changes, no bubbles forming, I can't observe the heat changes and things like that. And the solid that falls to the bottom is the chalk, which was already there. So none of these match those signs of a chemical change, so this is physical. All right. The chalk and citric acid. Initially, the citric acid and chalk mix, but after time, the chalk settles to the bottom. So same thing, happen again. Another physical change. All right. Chalk and vegetable oil. The chalk dissolves into the vegetable oil. So no color change, no bubbles forming. And this is the opposite of a precipitate forming because I'm not getting a new solid that wasn't there. All right. There's also, if I remember, oh yeah, dissolving. That's that one that Mrs. Pulling told us when we learned about this, that a lot of times people confuse dissolving for something more exciting, like a chemical change. But dissolving is a physical change. Chalk's still there. It's just being separated so far apart from each individual molecule that I can't see it anymore. Dissolving is a physical change. All right, so chalk and sodium hydroxide, no mixing, layers form with chalk on the bottom. All right, okay, none of this matches a sign of a chemical reaction. So all 4 of these were physical changes. All right, so don't be afraid if that happens a lot. You will see lots of physical changes in this one. And this is what I want from you as far as questions 1 and 2. All right, and you can even combine questions 1 and 2. You can make one big giant table that has all 24 like this, or you can have 24 sentences. All right, you could sit there and say chalk and distilled water initially mixed, but with time the chalk fell to the bottom. This was a physical change. All right, so these are your options as far as getting full points here. You can create a table that has all 24 in there, or you can give me 24 descriptions. All right, but just know, vast majority of students that lose points on this, it's because they don't tell me specifically about all 24 pairs of chemicals. So again, these are your questions. These 2 can be combined together into one table. Or you can create a table that has the chemical reactions and then another table that has the physical reactions. Either way works. All right, but just know, if there's not 24 pairs of chemicals that you talk about, you will lose points. And then question 3, we'll talk about a little bit more in a second. All right, so again, just repeating, you've got to talk about all 24. So my preference, a table is easier to read when you have that much information. And a table also usually results in less writing because you don't have to write complete sentences with a table. But if you don't use a table, better use complete sentences. All right, so there's tables like this. You can also make one big giant table that has all of them in there. All right, whatever works for you. I definitely prefer the table over a bunch of sentences, but you can write sentences too. Just know if I don't see all 24 pairs, there's going to be points lost, okay? All right, and then for question 3, looking for a paragraph. All right, this is not difficult to get to a full paragraph with. You can tell me what your hypothesis was. That's one sentence. Another sentence saying, oh, my hypothesis was supported, or my hypothesis was rejected. A third sentence saying why. All right, what evidence from your lab either supported it or rejected it. A fourth sentence can be, yes, hypotheses need to be correct for a lab to be successful, or no, hypotheses don't need to be correct. And then the fifth sentence is going to be your explanation why. All right, easy to get there. But just question 3, make sure you answer this one completely too. Okay, because again, I've been teaching this for years now, and I know this one is always a lab that honestly is easy. I just get students who sit there and give me like 3 sentences total as their discussion, and lots of points are lost because there's no way you're answering this whole thing in 3 sentences. So take your time to answer it completely. If you have questions, you're not sure if something is a physical change or a chemical change, just make contact. I'll help. All right. So that side's blank. We're done.